Hello and welcome to this lecture covering the default encryption options for your S3 buckets. Whenever you have sensitive data being stored in S3, it's imperative to have some level of encryption enabled as an additional layer of security to protect your data. Using default encryption, you are able to set a default encryption mechanism for every new object that is uploaded to the bucket. However, please note that for any objects that are already in your bucket prior to enabling encryption, they will not be encrypted. To enable default encryption on a particular bucket, you can select the default encryption tile from the Bucket Properties tab. This will enable you to configure one of the two different default encryption options. Firstly, AES 256, also known as SSE S3, which stands for Server-Side Encryption using S3 Managed Keys, and AWS KMS. This is often referred to as SSE KMS, which stands for Server-Side Encryption using KMS Managed Keys. KMS is the key management service, and if you're unfamiliar with this service, you can learn more about it in this course here. Let me explain both of these types of encryption at a high level, starting with SSE S3. Server-side encryption with S3 Managed Keys, SSE S3, requires minimal configuration and all management of the encryption keys are managed by AWS. All you need to do is to upload your data and S3 will handle all other aspects, making the encryption seemingly invisible to the end user. For the encryption process, firstly, a client uploads object data to S3. S3 then takes this object data and encrypts it with an S3 plaintext data key, and this creates an encrypted version of the object data, which is then saved and stored on S3. Next, the S3 plaintext data key is encrypted with an S3 master key, which creates an encrypted S3 data key. And this encrypted data key is then also stored on S3 and the plaintext data key is removed from memory. For the decryption process, a request is made by the client to S3 to retrieve the object data. Then S3 takes the associated encrypted S3 data key of the object data and decrypts it with the S3 master key. The S3 plaintext key is then used to decrypt the object data, and the object data is then sent back to the client. Now let's look at server-side encryption with KMS Managed Keys, SSE KMS. SSE KMS also allows S3 to use the key management service to generate your data encryption keys. Using KMS gives you far greater flexibility on how your keys are managed. For example, you are able to disable, rotate, and apply access controls to the CMK and audit against their usage using AWS CloudTrail. The encryption process is as follows. Firstly, a client uploads object data to S3. S3 then requests data keys from a KMS CMK. Using the specified CMK, KMS generates two data keys, a plain text data key and an encrypted version of the same data key. These two keys are then sent back to S3. S3 then combines the object data and the plain text data key to perform the encryption. This creates an encrypted version of the object data, which is then stored on S3 along with the encrypted data key. The plain text data key is then removed from memory. For the decryption process, a request is made by the client to S3 to retrieve the object data. Then S3 sends the associated encrypted data key of the object data to KMS. KMS then uses the correct CMK with the encrypted data key to decrypt it and create a plain text data key. This plaintext data key is then sent back to S3, and the plaintext data key is then combined with the encrypted object data to decrypt it. This decrypted object data is then sent back to the client. If you'd like to learn more about other encryption options available to use within S3 outside of the default encryption options, including server-side encryption using customer managed keys, client-side encryption using KMS managed keys, and client-side encryption using customer managed keys, then please see our existing course here.